Okay, hello distance learners. There's your warm-up. We're in the middle of it here in class, so you can go ahead and just work on that. You can pause the video. I want you to draw 3 diagrams just like we did yesterday, showing these fractions, what they look like, and also draw write 2 equivalent fractions for each one. Give it a try. Let's see how it goes. Go ahead and pause me and work on that, and we'll come back together momentarily. Looks good, folks. Ooh, awesome. What are you guys learning about here? I see the geography.
Oh, yeah.
Great Basin, Colorado Plateau. Wow, I feel like I would do really bad at this one.
I am really bad at this.
3 main factors that affect Utah's climate. Latitude and longitude, that makes sense.
I guess so.
Evaluation.
You just told us all this stuff.
Distance from the ocean. This is why I'm in math.
Yes, I know. I feel you.
Yeah.
That's why I don't look forward to it.
I like the phrase steppy climate, though. That sounds like, that doesn't sound like a band. That sounds like somebody's solo career. Like,
Yeah.
welcome to the stage, steppy climate. Woo! Steppy, steppy. Everyone at home is wondering what the heck's going on. All right. Can I get you guys up here in 5, 4, 3, 2, 1? Let's take a look at 9/15. In the interest of time, I would like to just settle 9/15. So 9/15, how many of you drew a rectangle to represent this? How many of you drew a rectangle? Just about everybody. You can certainly do a circle, or heck, you can do boy, I can't think of how you would cut up an oval into 15 equal pieces, and that thought actually really hurts my head. There must be a way. Is there? More on that later, maybe. I don't know. But you could do like a circle, maybe, or whatever you want. I like to do rectangles because you can get a little more creative with how you cut them up. So 15th, so 1, 2, 3, 4, 5. So if you used a rectangle, how did you cut this up? Did you cut it up into 15 little ribbons, or did you cut it up into a bunch of squares? Can you guys, how many of you did a bunch of little ribbons, just 15 little ribbons? That's interesting. A bunch of us, in my last period, the vast majority of students cut it up like this, which is totally fine. There's nothing wrong with that. I will say, though, guys, that if you were cutting this up like it was a piece of cake, those are some very unusual slices, right? So I'm going to cut it up like this. I'm going to cut it up into 3 slices this way and 5 slices this way. Do you have to do that? Yes or no? No, not at all. In fact, Abby from my 4th period, she was like, well, can I do this? And take a look what she did. Well, that's a good question. I love that. Was that Quinn asking that question? Yeah, it's true. Folks, there's nothing to stop you from cutting it up like that. And I don't know, half of you are going to be on my side and the other half are going to think I'm gross. When I eat cake, like I don't eat a lot of sugar, but when it's somebody's birthday, to be polite, I always eat the cake. And when I get access to sugar, I like go nuts. This is the slice I want, the one that's all frosting. How many people here are like me and want the slice that's all frosting? Yeah! How many think that's gross? That's fine. To each their own. I love it. Like, guys, I tell you, like, I'm terrible, man. Like, when I was a kid, I still do this. Well, not in 2020, I don't. But when I was at birthday parties, and like after the cake was cut, there's all the frosting that stuck to the board. I would absolutely take my fork. Oh, so good. It's the best part. Sugar, sugar. Anyway, so the point I'm trying to make is you can cut it up however you darn well wish. I like to cut it up like this because it makes it a little easier to talk about, especially given where I want to go with this. So I've cut this up into 15 squares. That's because the denominator tells you how many total pieces we cut it into. And 9 represents the total the pieces we have left. That's the pieces we have. So we're going to color in 9 of them. We'll do the edge pieces because it sounds like most of you guys are the folks who, you like the middle pieces the most, is that right? You guys like the middle pieces? 3, 4, 5, 6, 7, 8, 9. No pieces? You guys don't like cake? Yeah, that's how I feel. But I do prefer the corners because they have the most frosting. Anyway, so that's what 9/15 should look like. Now, folks, here's the thing. That is not what you would call a reduced fraction, because it turns out if you needed to cut this up into less pieces so that every piece was bigger, you could. How many of, if let's say that there were, let's say, how about this? You can cut these pieces right here, the orange things, into 3 slices so that they are all the same size. They won't all be the same shape the way that I've cut it. Wait, yes they will, if you're careful. But they will definitely be the same size. How many squares is each person going to get if I cut this orange part into 3 slices? Talk to each other and teach. Okay. That's okay. Can I get you guys back in 5, 4, 3, 2, 1? Let me show you what I mean. If I wasn't expecting 15 people at this party, like let's say I was only expecting, I don't know, I was expecting fewer and I wanted everyone to have more cake, I didn't have to cut it here. Let me see if I can get that to match the color to make it a little easier. That's better. You see how that piece now would be the same size as this piece? Do you guys see that? Each of those pieces represents one what? I guess I would have to do the same over here. And there's this one weird one right here. That's my piece right there. But they each have like 3 blocks, right? 1, 2, 3 blocks. So what fraction does that represent? I've got the 3 slices. How many slices have I cut it up into? Talk to each other, and here we go. Teach, teach, teach. Awesome. Very good. There's 5 slices, but how many do we keep? Love it. Let's get there in 5, 4, 3, 2, 1. I absolutely love it, guys. Let's see what we got out there. Oh, yeah, that's right. This is got to draw a bunch of empty cards because things are a little empty. This class is always a little bit small, which is just fine. Let's see here. Let's go. Here we go. Isabel, how many total pieces have I cut the cake into if I cut it this way? How many total pieces have I cut the cake into if I cut it this way? 5. That means that the denominator could be 5. And how many pieces do we actually have of those 5? How many pieces, Isabel, do we actually have of those 5? 3, which is why an equivalent fraction would be 3/5. We say that it's equivalent because if I cut it like this, or if I cut it like this, have I actually changed the amount of cake that I have? Yes or no? I would say whatever, and I would say? No. Do you change the amount of cake you have by cutting it differently? Yes. Maybe that's how much that's maybe you're talking. Okay, I think I understand what you're saying. Here we go. Don't worry, folks. If I cut it into, like, let's see here. It was these ones. Let's shade that in again. Whether I cut it like this or I cut it like this, is that the same amount of cake on the plate, yes or no? I'd say whatever, and I would say Yeah, the total amount of cake sitting on the plate is the same. That's why we would say it's an equivalent fraction. This is what we would call the reduced fraction, this one right here, because I actually can't cut it I can't cut my pieces any bigger. No, that would make them smaller. If I cut each piece in half, it would make each piece smaller. That's okay. I totally understand where you're coming from. Here's how you check if something's reduced. You have to ask yourself, is there a number? Well, maybe I should ask this a different way. Folks, is there something I could do to the number 9 and get 3 that I could also do to the number 15 and get the number 5? Talk to each other. Is there something I can do to 9 to make it a 3 and something I can do to a 15 to make it a 5? Talk to each other, and here we go. Teach, teach.
Wait, no. Unless you can do a fraction.
Make sure that's up and over, up and over. Thank you. What do you guys think? Beautiful, exactly. Excellent work. Okay, can I get you in 5, 4, 3, 2, 1? Ati, you said it perfectly. What was it, Ati? Oh, sorry, I actually couldn't hear Ati. Real quick. One more time. Exactly. Folks, this is what it looks like to reduce a fraction. 9/15, if you notice that a 3 goes evenly into 9 and a 3 goes evenly into 15, you can say, I'm going to reduce this by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. And there's an equivalent fraction. Now, question. Other than 1, is there a number that goes evenly into 3 and 5? Yes or no? I'd say what, everyone? I would say? 3. So 3 goes into 3. Will 3 go evenly into 5? No. And that's really all you got. 2.5? 2.5? That'll go evenly into 5, but even then you're really going to get something unpleasant on the numerator there, because then it's 3 divided by 2.5, and we're not dividing by fractions yet, or decimals, excuse me. More on that in a little later. That's how we would say that this is what is the reduced form, because there's no more numbers we can divide by and be done. Whew. With that being said, guys, I think we've got a better grounding for what fractions are. I want you guys to open your planners to page 42, please. Open your planners to page 42, or write this down in your notes. Hey, guys, happy National Attend Your Grandchild's Birthday Day.
What?
That's true, but perhaps you are one, and they could... Here's actually my biggest problem with this. It's not that not everybody's a grandparent. How are you supposed to celebrate this if your grandkids were born in October?
Somebody.
This only works if your birthday is 9/29.
No, every single day.
I would say someone actually said that. Really, every grandparent, for grandparents, every day that's not in 2020 should go to your grandchild's birthday day. This year, it'll have to be through a glass. We'll just do it through a glass, and it'll make up for some really sad photos. Hey, guys, planners, page 42. Page 42, beautiful, or get it on your notes. Look ready, guys, let's do it. Can I get you in 5, 4, 3, 2, 1? Red, what is our first essential question? Very good. The first essential question is, how can I add or subtract fractions that already have the same denominator? And our second essential question, I would like to see if I can get that one from, we'll get these out yet. Here we go. Auntie, what's the second essential question? Why do they act that way? Very good. Okay. Now I'm just going to close this to all those goofy sound effects because I know they get goofier as the class goes on because I've been having it all day. Anyway, I know, me too, but like I've been hearing it all day and I'm quite done with them. So let's write down a title for today's notes. Got a pencil?
Absolutely.
Adding and subtracting fractions with like denominators. And by like, I mean they have the same denominator. While you're writing that, by raise of hand, how many people here think they actually already know how to add and subtract fractions that have the same denominator? Who here thinks that you know how to do that already? Fantastic. But perhaps we don't know why. So let's see if we can figure it out. Let's see here. Adding and subtracting fractions, part 1. 3 parties. You can tell I wrote this before 2020 because it's about going to many birthday parties over the weekend. Please don't really do this. You go to 3 parties in the course of a weekend, and each has a cake like the one here. 3 slices by 4 slices, each the same size as the others, right? By the way, if it's 3 slices by 4 slices, I want you to notice it's 3 slices across the top, 4 slices like so. How many slices are there in one cake? How many, everyone, there are? 12 slices in a cake. Very good. You're going to 3 parties. We're talking about 3 cakes. Let's go ahead and draw those 3 cakes right here onto our notes. 3 rectangles. Yes, please. And we're going to make it so they're all the same size and that I'll show you. What's that? A 3 by 4. 1, 2, 3. And yours don't have to be as meticulous as mine because I have to make sure mine, 1, 2, 3, line up really well. But I will ask that you cut it just like it was in the picture. That is 3 slices this way. 3 cakes, that's right. 4 slices this way. Perfect. While you're finishing that up, I'm going to get a mint, you guys. I don't know. I have not yet found a food that is not horrific under your mask, like ever. I don't know what we're going to do. I can deal with that. Beats the lemon pepper turkey sandwich I had earlier. It was delicious. Don't get me wrong. It was yum-tastic. What's that? Those mints is mine. I'm going to run out of mints. All right. Let's talk about eating cake. Yay. Someone asked, is that you when you were a baby? And I was like, no, but this is certainly how I act now that I'm an adult. And there's cake. At the first party, 5 pieces of cake are eaten. Please shade in the cake that is left. If 5 pieces of cake are eaten at the first party, please shade in the cake that is left. That is left. Shade in the cake that is left. That's okay. Fix it. It's okay. That'll be an easy fix because there's more left than was eaten. That was a nasty cake. It was all frosting. There was no cake in it. Which means all 5 slices were eaten by me. So those are the ones that were eaten. How much would be left? Yep. That's an easy fix. I sometimes do. I do not feel great. It is not a good feeling in my stomach. Let's see here. Very good. Very good. Exactly so. Very good. Very good. Okay. Here we go. So, this cake can be yellow. If 5 pieces were eaten, that means there are 7 left, right? Gentlemen? It's okay. I'm not angry. Okay, how many of us were able to shade in 7 pieces, understanding that? You guys doing okay? 7 pieces? Yes? No? Okay. Next party. First party, 5 pieces were eaten, there were 7 pieces left. Second party, 10 pieces were eaten. How much is left? Teach!
Okay. How many people went to the first party compared to the second party? 10 pieces are eaten, nothing left.
Good, yes. 10 pieces are eaten, which means there's 2 pieces left, so shade 2 pieces. Just like the last one. It's okay. Do you have a second color?
No.
Redraw them real fast. It'll be easy. Uh-oh. Yes, let me get you the hall pass and go to the office and get another one. That's quite all right. Thanks for letting me know. Here you go, sir. Okay. Now, folks, if 10 pieces were eaten, how many pieces were left? There were how many? Everyone, there were whatever, and there were 2 pieces left. Good. Next. At the third party, 8 pieces got eaten. How many are left? Be very careful here, guys. Fill in that last cake and teach. That works too. Eight pieces are eaten, so how many are left? It's the same one. It's got to that point where it's going to make my voice sound funny. And I don't want the people at home have to listen to my slobbery mint voice all the time. So they have to listen to me crunch this down, which I'm sure is actually kind of annoying too. Anyway, can I get you guys back in 5, 4, 3, 2, 1? That is apt timing. I just drew this guy, the Australian card. No, but I have to do 5 minutes of the Australian here in the middle of the lesson. So, all right, let's go. If you eat 8 pieces, that means there's 4 pieces left, right? This cake's going to be blue, now green. It's a Seahawks green cake. Go Seahawks. I did, thank you. Excellent. Excellent eyes there, Quinn.
Wait, you said crying.
It happens, absolutely. And it's coming up because I know where this is going. Excellent. How many of us were able to get these filled in? Not exactly like mine. Something like that. You guys get the right idea. Oh, no. Just 2 of you. Wait a minute. How many of you were able to fill these in? Okay, guys. Let's see how many happy. Oh, that's better. Okay, excellent. I might come out to check you over there and make sure that's going all right. Now, perhaps you can see where this is going. Because it turns out you are stealing cake. In a fit of cake madness, you decide after each party to take all the cake leftovers. What are you thinking, mate? Crikey. How much cake are you taking home? You stealing all the cake. Look at your pictures and tell me how much cake you're stealing. Give it a shot and here we go. Crikey, all that cake? Teach! I don't think that's clear. We'll have to fix that up a little bit. 13 what? Perfect. Yeah, just hang it back up there. Thank you. That's looking sharp too, by the way. Now I got you right here. See, that mask is looking sharp right there. I like it. Perfect. All right. Your partners will get you on board with what we're doing with all that cake? Yes? Right. You should have shaded the ones that you kept. Now, if you went the opposite way, then you just add up all the white ones. They're all white cakes. It's fine. It's fine. It's an easy mistake to fix. Don't even worry about it. You guys get excellent. Excellent red. 13. Okay. Excellent. 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 All right. Okay. Interesting. Interesting. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1? Now, folks, in answer to this question, how much cake are you taking home? I've seen 3 answers today. They're all numerically saying something, but one of them is the one I like the most. And I want you to see if you can figure out which one it is. Now, almost everybody here got the most common one from a last period too, which is 13. How many of us wrote down 13? That's how much cake we're taking home. Okay. Then I saw some people write down 13/12. Anybody here write down 13/12? I saw a few of them. And then in my last period, I saw someone write down 13/36. My question is, gentlemen, no thanks, which of these 3 do you think answers the question the most just by itself? Because you'll notice nobody, and I actually haven't seen anybody do this today, put a label on it. So without a label, which of these 3 answers do you think tells us the most information about how much cake we went home with? Talk to each other. And by the way, when I say, crikey, that's a lot of cake, teach, what I want to hear from you is, crikey, that's a lot of cake. Okay, let's try that again. Guys, talk to your partners. Which of these 3 do you think best represents how much cake you stole? Crikey, that's a lot of cake. Teach. Excellent. You guys have got some good Aussie accents out there. Excellent. 1 and a 12. Very good. Excellent. Very good. Go ahead now, thanks. Go ahead and sit that down. Thank you so much. All right. Can I get you back up here in 5, 4, 3, 2, 1? Do you guys see this little crosshairs right here? Crosshairs right here? I want to know, when I'm over the thing you think I like best, I want you to give it a quiet little golf clap like this. Let me hear your politest little golf clap. Oh, it could be a little less polite than that. Can I get a polite little golf clap from you guys? Go ahead. Give me a little golf clap. You excellent wrist action. I like it. Now, when I'm pointing at the one you think I like best, give me that golf clap. If I'm pointing at one that you think I don't like the best, I want you to murmur unapprovingly. Let me hear a murmur that is unapproving. Wow, that's a lot of vitriol in that one. Because usually that happens, like somebody comes into a party they're not invited to, and everyone's like, oh my goodness, I can't believe they showed up to this party. But I like that in this case, if you were at a party and someone showed up who you knew wasn't invited, you'd immediately go, boo! All right, let's see it. What do you think of 13? Is that a golf clap or an unhappy murmur? Get a slow clap going. How about 1336? I agree. That's actually the one I like the least. How about 1312?
Yes.
1312 is in fact. Oops, that's not that. Yes, thank you. I almost started bowing. I don't know why. I was like, thank you. Thank you. All right. It's like the Vine Man from Little Prince. Anyway, 1312. That'll be 5 minutes for the Aussie. My question for you guys is, why do I like 1312s? What does 1312ths actually say about the amount of cake we walked home with? And it might even be easier to think about if you write down what Table C wrote down. Tobias and Red wrote down 1 and 1/12, because that is the mixed number version of the same number. So talk to each other. What does this number represent about how much cake we have? Teach. All right. Come on up in 5, 4, 3, 2, 1. Tobias, what does this number represent about how much cake we're taking home? Yeah, if you put all these together, you have enough cake to make a whole cake. Like, I was like, okay, I'm going to take these 2 purple pieces. I'm going to put them over here.
Or playing Tetris or whatever it's called.
Yeah. And then I'm going to take 6 of those yellow pieces and put them over here. I have enough to make a whole cake. And then I just have like a little plate over here with 1 cake. I'll just eat that one on the way home. Just stuff it down the gully works and eat it. Yeah. Anyway, that's exactly how it works. How many people here after seeing that once feel like that's not too bad, right? That's not too bad. So let's talk about it. Got a pencil? If we add or subtract fractions with the same denominator, do the operation, guys, I want you to write this down, please. Do the operation to the numerator and keep the denominator the same. And I hope that this cake example sort of illustrates why. That when I had 7 pieces of cake, I had 7/12ths of a cake, and then I had 2/12ths of a cake, and then I had, and let's look at that, yeah. I'll wait for you guys. That actually sounds like it might be a good idea to write down. Let's see. Okay. So for example, in this particular example, there were 7/12ths of a cake left, plus 2/12ths of a cake left that you stole second, plus 5/12ths, was it? No, 4/12ths of a cake left. And you add up all the numerators, and you ended up with 13 pieces, each one of which was 1/12 of the cake. Notice, the numerator changed, the denominator didn't. Let's do a couple of examples. Got a pencil? Oh, got a pencil? 3/8 plus 7/8. Folks, talk to your partners. If that's true, if I add or subtract fractions that have the same denominator, then I manipulate their numerators. I do the thing to their numerators, and then I leave their denominators alone. What would the answer be as a reduced fraction? See if you can figure it out. That's okay. We'll see what we can do. That's okay. That's why we're here, right? Talk to each other, and here we go. Teach, teach. Look at that. You finished it before I even said teach. That's awesome. Make sure your partner's on the same board, too. Oh, you even reduced it. Heck yeah. Well done. Let's go ahead and put the phone away. Thank you so much. Appreciate it. Okay. Does that reduce? Uh-huh. Like, is there a number that goes into 10 and 8? Very good. So we can reduce it by 2. If you guys get over here. That's right. Either one works. I'll take improper fractions or mixed numbers. Either way is fine with me. There it is. Excellent. That's it. That's all there is to it. See, not so bad after all. Okay, everybody, can I get you back up here in 5, 4, 3, 2, 1. Let's see if I can get a little bit of help. Ati, how did you do this? How did you do this one? So 3 plus 7 is 10. And then you just left that alone. 10/8 is beautiful. What did you do then? Because you notice that a 2 goes into 10 and 8, so you can reduce it by 2, giving me what? Very good. And then you change it into a mixed number, which was? Yeah. Guys, on your Canvas assignment, I will accept either 5/4 or 1 1/4. To type in 5/4, guys, you just do 5/4. To type in 1 1/4, 1 space 1/4. 1 space 1/4. There'll be instructions right there on your self-assessment. After seeing that one time, how many people here are not too alarmed by that? They're not too alarmed by that. Excellent. A couple of us. Very good. Let's do this example. Got a pencil? Got a pencil? Got a pencil? There you go. How about 2.5 plus 3.5? How could you do something like that? That sounded accusatory. I apologize. How could you do something like that? Give it a try, and here we go. Teach, teach. Make sure our hoods are off, thanks. Thank you. Yes.
Can you just take it and
You can, but it's still not reduced. Because is there a number that goes into 2 and 8?
yeah.
What number would that be?
The only number that goes into 2 is that.
Yeah, so 2, if we do 2 divided by 2, I would get?
1.
And 8 divided by 2? 1 and 1/4, just like we were hoping. Very good. Okay, everybody. Come on up here in 5, 4, 3, 2, 1. In the interest of time, guys, let me help you with this. There's 2 ways to think about it. One of them is to just add the whole number parts and then add the fractional parts and take it from there. For what it's worth, I think it'd be better to practice. I'll wait. There's still one more example we have to get through, whether that bell rings or not. Let's change these into improper fractions. 2 times 2 is 4, plus 1 is 5, so 2.5 is the same as 5/2. 3 times 2 is 6, plus 1 is 7, so it's plus 7/2. 5/2 plus 7/2, 8, 9, 10, 11, 12, that's 12/2. But guys, 12/2 is the same thing as 12 divided by 2. What is half of 12? Everybody, 12/2 must be? Let's talk it out. Guys, 12/2. What is half of 12? Teach. All right. Come on up in 5, 4, 3, 2, 1. Let's try that again. What's half of 12? Everybody, half of 12 is what? Everybody, half of 12 is? 6. Very good. I got one more example for you. One more and we're done.
Okay.
Let's focus up, guys. Got a pencil? Got a pencil? What is 3/8 minus 5/8? Talk it out. This one's got a trick to it. Teach, teach. Okay. That's okay. Let's do it. Can I get you in 5, 4, 3, 2, 1? We know that the denominator is going to be left alone and that subtraction is distance with direction. The numerator is just the 3 minus 5. If I'm going 2, 3 from 5, I'm standing over here on 5, and 3 is how many steps that way? 2 steps. Which way did I move? To the left, which is why that would be negative 2/8. Hello, negative fraction. I can still reduce that by 2 to get negative 1/4. We'll keep talking about this tomorrow. Go home and look at those self-assessments. I apologize. Last night, guys, the one that was supposed to be yesterday didn't show up until 7:45 p.m., which it was supposed to be a.m. My fault. Go home and look at those. We'll give those a shot. Say goodbye to the distance learners, everybody. Bye. Go ahead and work on that, guys, and we'll see you next time.